what I'm going to talk about is, because I know you're with the Workforce Solutions, right? So I'm
Mhm.
going to talk about just water in general, why it's important, how we use it, and then talk about drinking water and wastewater treatment plants, because those are jobs that are highly, well, they're in demand.
Okay.
So there's
And so
constantly,
let's talk about that. Like, what job a kid could do there, or and why it's important.
yeah,
Obviously,
I'll talk about that at the end.
yeah. And I didn't want to take away from any activity. You said a lot, or not a lot, but some of the kids are going to be, you're going to be connecting with them, or they're going to be connecting with you later this spring. So I didn't want to take away from your activities. How do you feel about questions? Do you want them to unmute their mics, or do you want them to put it in the chat panel?
Unmuting their mic is fine with me.
Okay.
Yeah.
Okay.
So,
All right. We have 6 classrooms ready. I'll give
okay.
you a few more minutes, and I'll open it up right at the 9 o'clock hour. But
All
if there's
right.
anything you want me to direct them on or forewarn them, or, obviously we're going to talk about water and the
Right.
importance of water and the roles within GBRA.
Right. Yeah.
And
And
then
so most of these kids are in Victoria, correct?
I'll ask them. So
Okay.
I'll ask them to put their school and their ISD in the chat box. And so that way you can figure out, because I don't know, I don't know if Gonzalez got the information.
Okay.
It went out to Region 3. So a lot of our Region 3 goes into the east.
Right.
Which
Yeah.
is more so like Matagorda, Wharton, and those I don't think would align to GBRA.
No, but the topic is still
Okay,
applicable.
okay.
Yeah.
So I just didn't want them to be like, oh yeah, we get water from GBRA. But you all service Victoria, correct?
Correct. And
Today we have Miss Cindy Thomas Jimenez, and she's with GBRA, and she's going to be speaking to us on the importance of water, what roles there are within GBRA, and how does their job affect our daily lives, and also what is GBRA, and how does it overall encompass our region. In saying that, if we could have you all put in what ISD you're from, as well as what school you're from in the chat box, we greatly appreciate that. Also, if you do have questions, feel free to unmute your mics. At that time, she will answer any questions or concerns you may have. And Ms. Jimenez, I will hand it over to you.
all right. Am I on the screen? Okay.
Yes, you are.
All right. I use so many different applications. By Friday, I get confused. Okay. So good morning. My name is Cindy Thomas Jimenez, and I'm happy to see that we have Cuero ISD on with us. And it looks like Victoria. I just had a staff member over at Vickers earlier this week. So some of this will be review, which is great. I love seeing students a couple of times, because I think that way the information sticks in a bit more. So GBRA, stands for Guadalupe Blanco River Authority, and we are what we call a quasi-state agency. So we are an agency that deals with 10 counties in the Guadalupe River Basin. And it's our goal is to ensure that all the communities and water users within those 10 counties have the water that they need for their whatever purpose. And also, we work very hard at studying the water in the river system to make sure that it's good quality water, especially when it comes to a city using water from the river for their drinking water. So I'm going to try to figure out how to share a screen. I have a short presentation, and somewhere in this presentation, I'm going to be going to the web to show you a couple of animations. So you'll have to forgive me as I fumble my way through that. All right, so can we all see the screen pretty well now?
Not yet.
Nope, okay. All right, it says I'm sharing the screen.
Yes, ma'am, now we're there.
Oh, okay, good. Okay. All right, so What we're going to be talking about this morning, we're going to start off with the water cycle. We're going to talk about stormwater runoff as well, because it's an important topic, and it's something that I think general citizens of all ages need to be more familiar with. And then we're going to go through looking at drinking water and wastewater treatment facilities, and wrap up by looking at different types of jobs that are out there in the marketplace dealing with water. So this is a physical map of the Guadalupe River Basin. So if GBRA has been to visit your 5th grade classroom in the last year or so, or 2 years, you may have seen this map before. We actually send this map out to 4th grade teachers, but I like using it when I give presentations, because I think it's really important for students to understand that this is a living river system. You've got lots of rivers on the map. You also have lots of other little creeks. Hopefully you can see my cursor. Here's the headwaters of the river. You've got a lot of little creeks in here feeding in. And all of the water on this map eventually ends up in the Guadalupe River. So this map is a physical map, and it's basically showing you elevation. Because water is always moving downhill. And the final destination of our river system is the Gulf of Mexico, specifically at San Antonio Bay. So really every major river system in the state of Texas is headed to the Gulf of Mexico. And that's because water is headed downhill. So it goes from a high elevation to a low elevation as gravity pulls the water down. So this gray and brown part of the map actually represents the Texas Hill Country, which is where our river originates. It's a spring-fed river up in Kerr County. You see there are 4 major streams up there, but they all feed into the main river itself. So it is a stream that is moving downhill, and this elevation is pretty steep in this area. It goes from 1,800 feet above sea level, which is up here at the headwaters. And it flows, when it gets to this point, it's about 900 feet above sea level. And that's a lake that we have called Canyon Lake. So that's a 950-foot drop in elevation right there. We do have a little flood control dam at Canyon Lake. And then once the water leaves that lake, it heads into this dark green part of the map, which is the Blackland Prairies of Texas. And so here we see a lot of farming taking place. And right now we have some very large urban areas that are growing. And that's in the San Marcos, New Braunfels, Seguin area. But this is about 600 feet above sea level. In this area, we have the Blanco River coming down. It goes into the San Marcos River, which joins up with the Guadalupe here. Now this light green part of the map is the coastal plains. So where the Guadalupe and San Marcos River joins is in the city of Gonzales in Gonzales County. So here, as I said, it's the coastal plains of Texas, and that's where Cuero is located as well. So things really start to flatten out in this area. Gonzales is about 300 feet above sea level, and Cuero is about 200 feet above sea level. Once the river leaves Cuero and heads down into Victoria County, this is what we call the Gulf Coastal Prairies and Marshes. And so here, the land is really starting to flatten out. I think the city of Victoria is around 90 feet above sea level. And you have a lot of marshland, bogs, bayous, swamps, whatever you want to call it. The river is actually very, very different down here. And eventually it goes down, it forms a boundary between Refugio and Calhoun County. And then just to make a note here, we also have another river coming in, and that's the San Antonio River. Some of you may not realize that the San Antonio River that's in downtown San Antonio, and on the map, that would be right up here, that river flows down and it joins up with the Guadalupe River about 8 miles from the coast. And then the Guadalupe River, the fresh water in that river blends in with the salt water at San Antonio Bay. Now, I also wanted to show you this map. It's just a map showing you all the counties that are dependent on the Guadalupe River and some of the cities. The cities that I have noted here are the larger cities in the river basin. One of them up in the hill country is the city of Boerne. San Antonio is not in our river basin, but it does play a big role in our water. And so does the city of Austin. You know, Austin's over 1 million people. San Antonio's over 1.5 million people. And we're kind of sandwiched in the middle between those two big urban areas. So there's a lot of competition for water because the population of these cities are growing very, very rapidly. The cities of San Marcos and New Braunfels are two of the fastest growing cities in the United States. And I don't know if any of you have ever been to those cities, but if you haven't been lately, when you go back, if you get lucky enough to go back, you're going to notice they look very, very different. Also here is the city of Seguin. That's where my office is located. Once you get into this area, there's a lot more agriculture. Up in the hill country, they do some animal grazing like goats and sheep and stuff like that, but there's not a lot of soil, so there's not a lot of agriculture. But once you get into the Blackland Prairies area and south, you see more crops that are being grown, more animals, like around Gonzales. There are lots and lots of huge cattle farms and poultry, same as true in Cuero, in DeWitt County, a lot of big poultry farms and lots of cattle. So the river system is used for these agricultural uses. And then up here, the river system is used for people. You know, these are cities that get their drinking water from the Guadalupe River. As you head down past Cuero into the Victoria area along the coastal bend, you'll see even more agriculture. And the crops change a bit. Up here, there's a lot of cotton and corn and milo that's grown. As you get down into this area, we have some of those same crops, but we also see rice that is being grown. And so we have people who pull water from the Guadalupe River to irrigate those rice fields down in Victoria and Calhoun counties. It's a big industry. All right, so that's the river system. Now I did want to just touch on the water cycle. I know you probably learned about it in 4th grade, but it is a system that is ever going on. It never stops. It never ends. There's no end and no beginning. But typically when we look at the water cycle, we start with evaporation. And the interesting thing about water is that it is sorry, I got to look at my watch so I can pace myself. It is water can be found in either a solid or a liquid or a gas. Now, typically when we think of water, we think of liquid water. That's what comes out of our faucets. That's what we see in streams and lakes and things along the side of the road. So as it changes from a liquid to, as through evaporation, it becomes a gas or vapor. And so then that water vapor starts to gather up in clouds, and this is called condensation. And eventually some of those clouds may get so heavy with the water vapor that it will fall back to the Earth's surface as precipitation. Typically around here, we see rainfall. But occasionally, you know, it seems like just yesterday, but I think a few weeks ago, we actually did have snowfall and we did have ice. So those are examples of solid water, you know, water that is a solid. But typically we see liquid precipitation. And when the water comes back to the surface, it's either going to start to percolate down into the ground or it's going to form little streams of runoff that will feed into small creeks, which will then feed into larger creeks, which may then eventually feed into a river or a lake or down into a coastal body of water. Another thing to remember is that we also have water underground. This represents an aquifer. So in our Guadalupe River Basin, we actually have 4 underlying aquifers. We have 2 limestone aquifers up in the hill country. In the middle there, we have a sand and gravel aquifer. And then down in the area around Victoria, and I believe Cuero as well, it is a sand aquifer. And all these aquifers are a little different in how fast they take in the water and how fast the water moves through the system. Another thing you want to stop and think about is transpiration, and that is where we have vegetation, any type of growing organism, plants, grasses, shrubs, flowers. And those plants will also give off water through what's called transpiration. And that water goes back up into the water cycle system and continues to move through the cycle. Now, I wanted to talk a little bit about stormwater and surface water runoff. So we're talking about precipitation. So water comes to the surface from the sky, right? And then it gets on the move. And so we have a lot of different ways that we use the land. We have forest or just open farmland, ranch land that is not heavily used by people. I mean, we do graze crops on it, we do raise animals, but it's a little bit different than what we see in the cities. So in the cities, you have a lot of development, you have lots of buildings, you've got schools, businesses, office buildings, shopping centers, gas stations, restaurants, you name it. And that's going to make a big difference on the water that trails into the river. The same is true of suburban development. And then over here, we do actually show an animal feedlot. And there are quite a few of those in DeWitt and Gonzales counties. So what happens is we have all these different ways that we're using the land. And so all of those different land uses are going to have an effect on how clean the water is that goes into the river. So runoff, as I've mentioned before, doesn't go directly into a wastewater treatment facility. Typically, I'll ask kids, have you seen when it rains, there's little streams of water heading down in a city anyway, into a gutter on the side of the road. And most students have seen that. They've seen those little outlets or inlets is what they are. But I ask them, where does that water go? And it goes into, that little gutter. Where does it go from there? And a lot of students seem to think that it goes directly to what they call the sewer. And we call that a wastewater treatment facility. But that is not what happens. That water that goes into those little gutters on the side of the road actually goes directly into a creek, a river, a lake. So all the things that we were doing out on the land in our cities and suburbs and farms and so on, whatever pollutants there are, and that could, from the city, it could be oil and gas coming off of our roads. From the suburbs, it could be pesticides and fertilizers coming off of our lawns. From the animal feedlot, it could be excessive nutrients from the manure. So all that stuff can get caught up in the runoff and head into the river system. So we call that type of situation non-point source pollution, because we study these rivers a lot and we know that these rivers have pollutants in them, but we don't know exactly where it's coming from. In other words, we cannot point to exactly where that pollution comes from. So it's really challenging for the people who run our drinking water treatment plants to treat that water. They have to study that water, know exactly what's in it, because they have to clean that water before it goes to your homes and businesses and schools. So this question is, how does clean drinking water get to your house and to your schools and businesses? So I'm going to go to a little diagram here first, and then we'll look at an animation. So this is a term that I think students think is kind of funny. In the water industry, we're very familiar with it. The term is raw water. Well, what does that mean? Well, think about the term a raw egg. Is that something that you would want to eat? Well, probably not. So the same is true with raw water. You don't want to pull water directly out of a river or a lake to send directly to people's houses. So we pump the raw water out, that's water straight out of the river, and it goes through a treatment system. It starts off with something called pre-treatment, where we add a little bit of a chemical. That chemical is used to start to attract whatever dirt or sediment is in that water and kind of clump it together. So it leaves that tank, it goes into what's called the flocculation tank. And so, as I said, we put the chemical in to try to get that dirt to clump together. We call that clumped dirt, we call it floc. It's spelled F-L-O-C. And in this basin and action where all that floc is being starting to pull together is what's happening in this basin. Then the water goes to a sedimentation basin where that floc starts to settle to the bottom. So here we kind of just let it sit and settle. And then we take clear water from the top of that tank and it goes into some filters. Typically those filters are made of sand and gravel and coal. And so that further filters out any other types of organic material that could be in the water. And then it goes into a tank where a water company does some type of disinfection. There still could be things coming through the filters. It could not be good for people to ingest. So we use some type of a disinfectant, something like chlorine or something. They put a limited amount, but just enough to kill anything that could be in there that could be harmful, specifically bacteria. And from there, it goes to this water treatment plant. It goes to this water tower. A lot of times I'll ask students, where does your drinking water come from? And, sometimes I get, well, it comes from the faucet, or it comes from HEB, or it comes from the water tower. But as you can see, looking at this, there's a long process that takes place before it goes into the water tower. And then from the water tower, then it goes to your houses. So I'm gonna take you to an animation really quick. I think I can still do this. What do y'all see on the screen now? Can somebody tell me? Hello? Hello?
Educators, if y'all could put your answers in the chat panel.
Do y'all see a diagram that says drinking water treatment plant?
Yes, ma'am.
Okay. So I'm going to go ahead and run this animation. And it's not exactly the process I just mentioned, because this one has an aerator. The other diagram I showed you did not have that, but some water plants do. So they run the water through this, they kind of get it churned up. Then they sent it into this mixing area where they're adding that chemical to start to get those particles of sediment and dirt to clump together. They're mixing in that coagulant here. And once they get it mixed up, then it's going to lead down into what's called a clarifier, where that flock will start to settle. You can see the water comes up, it goes through the top, there you go, and all that flock starts to build down at the bottom. And then clear water goes over through this filter system. And then from there, here, this one says ozone unit. That's just another way to disinfect water. And then it goes up into the overhead tank. All right. Sometimes what we don't think about is there is a process where the sludge or that flock that gathers at the bottom of the tank, it has to be dealt with as well. So we call that sludge, we gather it in another tank, and we kind of cook it for a while, basically. And then we put it out in some what are called drying beds. So out in a field, they'll just have, rows and rows and rows of sludge that's out there drying. And eventually that sludge can be used. Some people who make organic fertilizer might actually buy that sludge and use it to make that organic fertilizer. So I'm going to close that and go back to my other presentation. So can somebody tell me what you see now?
We're still seeing the PowerPoint now. Okay. Going into the animation PowerPoint.
Or is the animation finished?
It says what happens to water after.
Oh, good. Okay. So what happens after you use it? So we saw the raw water was treated. It went up into the water tower. And then what do you use it. So what happens to it after you use it? Well, let's take a look at how you use it first. So we use it to wash our dishes. Some of us do our dishes by hand. Some of us do it in a dishwasher. We also use water to wash our clothes, all right? We also use water to wash our hands or to brush our teeth or other uses in the home. Maybe you get water from the faucet there for your dog or cat. We also use water to bathe in. And we also use water to flush our toilets. So we have all this clean water coming in that we're using through, all these different ways. But then after you use it, what happens to it? So what happens to it then is a separate pipe that leaves your house, and it goes to what we call a wastewater treatment plant. And so this is an entirely different process from what you saw before. What you saw before was drinking water treatment plant, where they take that raw water and get it clean enough to send to your house. And then with the wastewater, they take your dirty water away and they send it to another place, this wastewater treatment plant, where they send it through a process to get it clean enough to basically, they're going to put that water back out into the environment, out into a river or a creek after they get it super clean. So this process, we've got a bar screen, a grit chamber, a clarifier, an aerobic basin. This is a lot more complicated. And we have a secondary clarifier From there, you know, we might run it through filters, we might do a chemical treatment, we might, and eventually though, we have to, you know, we're putting chlorine in this water, like here, or some type of chemical, but we can't take water with a bunch of chlorine or a chemical in it and then just dump it into a creek or river, because that won't be good for the aquatic life in that creek or river. So after we chlorinate it, we have to dechlorinate it. So we put something in it and then we have to take it out before we put it back into the river. So I have another animation to show you. So I'm gonna stop that and, well, maybe I can do it within, maybe not. Let's see. I'm not very good at changing screens in Zoom. I'm very sorry, but I'm doing my best. I hope y'all are still with me. I think I actually, okay. All right, so here we have, this is actually on our website at GBRA, and it's an animation where you can follow the water through. So you can see, are y'all seeing an animation now? It says start tour. Is it moving? Does it say
no,
wastewater?
No.
You're not seeing? No.
We just see the slide that states wastewater treatment.
All right.
But it was not moving, it was still.
Okay. Mm-hmm. Well, I don't know if I'm going to get you that. But basically, I'm going to send y'all a link. But basically, it just shows you, it's an animation that you can work through yourself, and you can see the water moving from the, this is an area where we take out trash, because you'd be amazed at things that go down people's sinks and toilets. And then you can just work your way by yourself through this process to see how the water gets clean before it goes back into a creek or river. All right, so the last thing I wanted to talk to you about are jobs. These people who work at these drinking water plants and wastewater treatment plants are critical jobs, because your health is dependent on those people if you stop to think about it. So the water that a drinking water treatment plant puts in your house is very highly regulated. The federal government, the EPA, and then the state government, the Texas Commission on Environmental Quality, and EPA stands for Environmental Protection Agency. Those two agencies have very high standards for drinking water. So when the water leaves a drinking water treatment plant, it has to be super, super clean. It cannot have anything in it that could possibly make you sick. So that's a lot of responsibility. So we take these jobs very, very seriously at drinking water treatment plants. And then the wastewater jobs as well are very, very important, because they take the water that we used, they clean it, and then they put it back into a river system or a lake or something like that. So we then, as humans, might go into that river that has this wastewater in it, right? We might go swimming in it. We might go tubing in it. We might go kayaking. We might go fishing. But if our skin is coming in contact with that water, we need to make sure that the water in that river system is, you know, safe for us to do that. So the wastewater jobs are just as important as the drinking water jobs. So as our population grows, I know down in the Victoria area, there's a population growth taking place. Up here where I am in the New Braunfels and San Marcos and Seguin area, the growth is just really, really fast. So many houses being built, so many people moving in. And so when you have growth like that, you need water. You need water for those people to have in those new subdivisions and those new businesses. So these jobs are much in demand. There's a lot of competition between drinking water companies to get what are called operators. And so you can actually start as an operator in high school. There are different levels of operators. There's a D level, a C level, a B level, and an A level operator. And so if you were to get a job at a drinking water or a wastewater plant, you would start at the bottom. You could go to college and continue. You'd make a little fast track up that step ladder if you were to get some of that education under your belt. And if you don't want to go the route of college, then your drinking water or wastewater plant will actually send you to classes, and those are all paid for. And so slowly you can make your way up that ladder. So these jobs are so much in demand, I can't even stress it. And I think as time goes on, they're going to be even more in demand. So as you're thinking about what you want to do with your life, if you want to do something that helps people, working at a drinking water treatment plant is a great idea, and working at a wastewater treatment plant is a great idea as well. So in your community, you have drinking water and wastewater plants. I'm not that sure about Cuero. I think that the majority of their water is groundwater, but it still has to be treated. It still is regulated by EPA and TCEQ. In the city of Victoria, your drinking water comes from the Guadalupe River, and the city of Victoria operates the drinking water treatment plant. And in Victoria, the city also operates the wastewater treatment plant. So I just wanted to remind you that water is a precious resource and that we need to do what we can to conserve it. And by conserve it, it doesn't mean that we just need to not be wasteful with it, but we also need to be very aware of how our actions can impact it. All right. So are there any questions for me? And for some reason, I cannot see the chat.
At this time, there's no questions. Educators, if you do have questions, please feel free to unmute your mics or put your questions in the chat box. Thank you.
I don't see anything. So
we have a question.
Okay.
Okay. What is it, Wendell?
Do they filter salt water or just fresh water?
Do you filter salt water or just fresh water?
Well, that's a very good question, because as I said, there's more and more of a demand for water. And for the most part in Texas, we use fresh water. However, as our population continues to grow, there are a lot of plans for the future to actually pull salt water from the ocean and use that. So that would go through a completely different process to get that salt water out before it could be used for drinking water. It's a bit of a more costly process, but supply and demand, if there's a big demand for something, which would be fresh drinking water, and there's not a lot of water in our rivers or aquifers to work with, then I think we probably will go that route and people will be willing to pay that money. I don't really know how many gallons of water you might want to ask. Well, you could actually take this to your house. You could have the students go back and ask their parents to look at their water bill, and it will tell them how many gallons they use each month. And then you could also reach out to the drinking water treatment plant to see how many gallons of water are treated there. So you'll know how much the entire city of Victoria uses. GBRA, actually, we permit water out from the river, which means we don't measure in gallons, we measure in something called an acre foot. So an acre foot is, if you can picture an acre of land, which is basically like a football field, and then have 12 inches, like a foot of water on top of it. So that's 1 acre foot, and it is equivalent to almost 326,000 gallons. So we measure in acre feet, we don't measure in gallons, so that's why it's kind of hard for me to answer that question. Are there any other questions? If not, I'm going to put the link for that wastewater treatment animation here in the chat, so y'all could get to that.
Another question.
What's that?
Is there any dangerous parts about some of these jobs?
Well, they do use some chemicals that are fairly dangerous, but of course they are in tanks, and those are inspected, I think, monthly. And so for the most part, what bit of danger there could be from those chemicals is very well contained. And one of the things that can happen with a wastewater plant is that if we have a really big flood event, and we typically are known for that here in the Guadalupe River Basin, we haven't seen one in a while, so you students probably haven't seen a really big flood yet, but the odds are you probably will. So like back in 1998, we had a huge flood event that impacted everybody from Canyon Lake all the way to the coast. And in the city of Victoria, one of the things that happened was the wastewater treatment plant went underwater. So of course that meant there's just raw sewage, which has a lot of pathogens in it, things that are not healthy for humans to be in contact with. So we had a lot of raw sewage actually going into the river at that point. So that could be something that is dangerous to try to corral that and get all that, stop, we have to of course wait for the flood water to go down, but then you have to really stop and just flush out that entire system and get it up and running again.
Do workers have to wear protective gear?
They wear hard hats and safety glasses for the most part. Yes, very good question. And so I have, do the chemicals stay in the water after it is treated? For example, in drinking water, there will be a residual of some, whatever disinfectant they're using. Sometimes when you get water out of the faucet, it tastes a little bit funny, and that could be the reason for that. So if you do feel like your drinking water tastes a little funny, you should reach out to your drinking water treatment plant and find out what's going on. With the treated wastewater, there are no chemicals that are in that water that's put back into the river. Any other questions?
One of my students wants to know if some of the chemicals are left in the water, what kind of repercussions would that be?
Well, I don't think the chemicals from the treatment plant would be left in the water. What we could see happen, which is kind of what happened with our winter storm, is that basically there wasn't enough water moving through those systems. So there could have been a bit of a lack or a excess of chemicals in that water. And that's why we had so many boiled water notices. So if you did drink water that had some type of contaminant in it, those chemicals, then it could make you sick to your stomach and, have an upset stomach, maybe diarrhea or something like that. But typically, if there's anything wrong with any water coming out of a drinking water treatment plant, they have to alert the public that you cannot drink this water. You have to boil it before you can drink it. Well, if there are no other questions, I have to run off to another location and do a presentation for a bunch of teachers. So.
Thank you so much, Cindy. And educators, if you do come across a question that your students would like to have answered, please feel free to email me and we can relay those to Miss Cindy, and we will get an answer back for you. We appreciate you all connecting and thank you all for your time. You all have a safe day and enjoy your spring break.